Hey guys, Mr. Betts here. Let's take a look at a couple examples of the product rule that use multiple representations of functions. So in this particular problem, we have h of x as a function defined as f times g, and we are given information about f in a graph, and we're given information about g in a table. So we're mixing graphical presentation with numerical presentation, and we want to find the derivative of h at 1. So first thing I'm going to do is I'm going to take this definition of h here as f times g, and I'm going to take the derivative of that using the product rule. So the derivative of h is going to be the derivative of the first function, which is f. So derivative of f times the second function, so just times g of x, plus the first function, f of x, times the derivative of the second function. Okay, so that's just the direct product rule right there. Now we want to find h prime of 1. So to do that, we are going to plug in 1 for x. So we have h prime of 1 equals f prime of 1 times g of 1 plus f of 1 times g prime of 1. Now, what we need to do at this point is take the information from the graph, take the information from the table, and plug it in as appropriate in this expression. So f prime of 1 is the derivative of f at 1, so the slope of the tangent line at 1. Conveniently, f is a straight line, so the derivative of f at all points is just the slope of that line, and the slope of this line is 2. So f prime of any number, f prime of x is going to be 2, but in particular f prime of 1 is going to be 2. And then we have g of 1. So g of 1 is going to be given to us right there. So that's going to be times 7 plus f of 1. So f of 1 is just the value of the function at 1, which in this case is negative 1, and g prime of 1. G prime of 1 is going to be negative 3. And at this point, we can actually just box that and be done. Remember, if you have a numeric expression that would simplify to the right answer, you can be done. I'll go ahead and simplify it though. So we have 2 times 7 is 14, plus 3 is going to be 17. In our second example here, we've got a combination now of analytic presentation, which is just the e to the x function, and graphical presentation. So g is defined as the product of e to the x and f of x, and we want to find g prime of 2. So just like the last problem, I'm going to take this equation right here and take the derivative using the product rule. So the derivative of g is going to be the derivative of the first. The first is e to the x. Derivative of e to the x is e to the x, times the second, plus the first, so the first function is e to the x, times the derivative of the second. Now we want to find g prime of 2, so we're going to plug 2 in for x. And then we're going to replace our f of 2 and our f prime of 2 using the information from the graph. So f of 2 is just the value of the function at 2, which is going to be 5. So g prime of 2 is going to be e squared times 5, and then plus e squared, and then f prime of 2 is the slope of the tangent line. Tangent line is given to us here, and it looks like that has a slope of 1. It's pretty clear here that it's going through those lattice points, so that has a slope of negative 1, and that's it. We don't have to do anything else. If we did simplify here, we're going to have 5e squared minus e squared, which would be 4e squared.